So guys, here is our second speaker, Dr. M. Vishnu Prasad sir. Vishnu Prasad sir is a strategic HR division head at Unistring Tech Solutions, where he leads initiative to align talent acquisition, capability building, and training with organizational growth and long-term strategic priorities. He holds a Doctor of Philosophy (PhD) in Electrical Engineering from National Institute of Technology, Warangal, an accomplished academician and industry professional. Dr. Vishnu Sir brings over a 14 years of combined experience, including 10 years in research and academy and 4 years in industrial practice. As a keynote speaker, he offers a balanced perspective that bridges theory and practice, sharing insights on how strong research foundation, disciplined engineering methodologies, and real-world industry exposure together enable the development of robust, scalable, and application-ready engineering solutions. So we heartily welcome our second speaker, Dr. M. Vishnu Prasad sir. Sir, over to you. You may continue, sir.
Yeah, thank you, Harsha, for your wonderful introduction. So I hope my cam is visible and I'm audible.
Yes, sir.
Thank you. Please stop sharing the screen. So I hope my screen is visible.
Yes, sir.
Yeah. So thank you, Harsha, for your nice introduction. So first of all, I'd like to welcome you all the participants and resource persons. Uh, Warm greetings from the Unistring Tech Solutions, and I thank Gyanidhi Innovations to invite me for this keynote session. So yeah, so I'm the Dr. Vishnu. I'm heading the strategic HR division at Unistring Tech Solutions, and UTS is the subsidiary of Gen Technologies. So first of all, first 5 minutes I'll run through the UTS profile. Then I'll walk you through the whatever the competencies, skills that are required for electrical and electronics engineering, manufacturing sector. Particularly, I'll emphasize on the hardware side. Okay. Yeah. All right. So Unistring was established in the year 2007, and we are into the defense electronic warfare products, majorly anti-drone systems. So we can proudly say that we are the only Indian company to build end-to-end anti-drone system that is complete indigenously. As on date, we are having more than 600 employees, roughly around 650 employees. In that, 50% of employees works on R&D teams. So we are having 17 years of experience in electronic warfare and radar products. As I mentioned, we are the subsidiary of Gen Technologies, and we are having multiple patented products in the area of radar and electronic warfare. And our vision is to become the global leader in design, realization, and supply of electronic warfare systems. And to achieve that vision, and our mission is to provide the innovate, high quality, and cost effective solutions through a steadfast commitment to excellence and continuous improvement. So you can say who are our end users. So you can see our key clients or end users are Triforces, Army, Air Force, and Navy. And we deliver our systems to these tri services through our parent company Gen Technologies, DRDO, and Bharat Electronics. That means whatever the products that we are developing at UTS are used by the Triforces. And this is our journey in the counter drone system or anti drone system. So the first system was installed at Red Fort during Independence Day celebration in the year 2020. This is the first version, and so UTS is partnered with other private industries and government organizations. So that is the first version, and we have delivered a part of this system, subsystem of this whole system. And later, if you see in the year 2023, a full-blown vehicle-based system was manufactured by UTS. And thanks to the government of India for these initiatives like Make in India and Atmanirbhar Bharat. So we fully believe in these two uh, initiatives given by government of India. Okay. So this is the latest Republic Day celebrations. I hope, I think sound will play. I think there is a problem in the video playing. However, this is the parade during Republic Day, recent Republic Day celebrations, and we have displayed our system. And this is our leadership team. So UTS was established by two visionary scientists from the DRDO DRDL. So Dr. S. Nagendra Babu, he's a DRDO person. He's with the mechanical background. He came out in the year 2019 and taken the charge of managing director. And Mr. K. Srinivasa Raju, he worked with DRDL and he came out in the year 2014 and took a charge as CEO. So he's with the electronics background. So these two people are the strong leaders in terms of, so they mentor all our technical teams in terms of these complex anti-drone systems. And Dr. Shravani Madam, she's the Vice President. She is looking after the HR and supply chain divisions. And Miss Nicola ma'am is vice president. She's looking after inventory and operations. And Dr. M. Lakshmi Narayana sir, he is the head R&D. So if you are active in IEEE societies, so he's the one of the active member you can meet. So he's especially mentoring our antenna design division. And from Gen Technologies, we are having Ms. Silpa Chaudhary and Ashok Katleri as the directors. So this is our leadership team. And wherever the defense and aerospace exhibitions are happening, definitely UTS and Gen Technologies representation will be there. You can see all the key personnel, including our Rajnath Singh Defense Minister and other armed forces people you can see in the pictures. So yeah, so they will frequently visit our uh, stalls, and they will keep on interacting with our MD and other team members. And so all the top level officials of Triforces and defense sector, so they know UTS and Gen Technologies very well. And I'm not going into the deep because we are having a limited time. So UTS develops both digital and RF hardware. So RF hardware up to 20 gigahertz, and we develop our own software that will be using in whatever the drivers development. All those things will be developed at UTS and by the software team. Even the maps, GUIs, graphical user interfaces, whatever the things that are used in the final product, that will be developed at UTS. So that's why we are calling it as indigenous, right from the design, manufacturing, and installing and maintenance. So everything will be done by UTS team. So as I mentioning, counter drone system or anti drone system. So recent, so a year back, so Operation Sindhu. So they have displayed our, see, while DGMO addressing the operations in about the Operation Sindhu. So they have displayed this. So you can see the product developed by UTS. You can see in this picture, and these are the various appreciation letters received by our employees during Operation Sindhu. They presented the bases, army bases, and they have supported our armed forces. So these are some of the appreciation letters received during that time. And this is our leadership team addressing the various mm, media regarding post Operation Sindhu. And this is full vehicle based system where detection systems and jamming systems are there. So I'm not going into much detail. So we see whenever we are having other opportunity to discuss about these things, yes, we'll go in deep. So maybe this is a continuous series. So we are hopefully we are going to have these sessions in this series. Right now, I'll start with the today's agenda, that is hardware competency framework for electrical and electronic manufacturing. So this talk is majorly designed for ECE and Triple E students, particularly the graduates. I hope whoever joined this session, they're 2027 26 graduates. So those who are looking for the opportunities in electronics sector, that is core sector. Okay, so we'll start the session. Yeah. So if I say what are the different electrical and electronic manufacturing sectors, so I have given major sectors here. So these major sectors can be subdivided into several other sectors. Somebody is writing on the screen,
Yeah,
I
yeah,
think
please.
Darshan Hegde. So please stop that. So please undo your action. Yeah, thank you. Right. So yeah, consumer electronics like your handheld and wearable devices, and we're having semiconductors right from microchip fabrication and electrical equipment and components in the power generation and distribution, and aerospace and defense where our UTS comes under defense sector. So and automotive electronics like electric vehicles and other transportation systems, and industrial automation like your robotics and factory systems, medical electronics. You can see in your ICUs all the electronic equipment for diagnostics and monitoring, and telecommunications for all your communications, and renewable energy and power storage. Again, it comes into the electrical sector. So these are the major sectors for where the manufacturing opportunities are there. So the objective of this session so is that, see what are the different roles are available, and what are the job functionalities, their responsibilities, and what are the skills required to get those jobs or internships. If you are in final year, we'll offer internships. So what are those skills required? So that we'll discuss here. So maybe at the top level we'll discuss, and whenever there is a detailed session about each role is there, yes, we can have the detailed discussions. So if you see any electronic product, so it is a combination of different modules. So I hope everyone knows the difference between component and a module, right? So component is the individual entity where so the structured connection of these components forms a module to achieve a specific task, right? So this is the difference between a component and a module. So if you are using different modules for the specific purpose, right? So your inputs are defined and your outputs are defined, so that by using the different modules, you can build a system or subsystem. So here LRU could be a system or it could be a subsystem. So let us say this is one electronic subsystem, right? So what are the building blocks for this electronic subsystem? So if you see modules, cables, and connectors. So connectors are used to interconnect between these two modules. So any electronic system is having the combination of modules, cables, and connectors. Okay, right. So here I'm emphasizing on the different hardware roles. So anyway, PCB design will be covered by Mr. Balu Naik sir, the MD and CEO of DBLNS. So maybe the subsequent session. So I'm not covering the PCB design role, the skills. So I'm covering the other hardware roles, that is product design engineer, product integration engineer, functional testing engineer, and quality control engineer. So these are the major categories. Even under these four categories, even there are several subcategories are there. However, for this session, we'll concentrate on these four major categories. Okay, so these four engineers plays a major role, particularly from the hardware side, in the any electronic product development. Okay, so we'll start one by one. So first, we'll discuss about electronic design engineer. So the responsibility of electronic design engineer to design the system or subsystem or a module. So he can design a module. So that is mostly at PCB level. So if the modules are available, a subsystem need to be designed. So any electronic design cycle starts with the requirements and specifications. So this will come from the customer or end user. So the first step is understanding the requirements and specifications given by the customer. So here we are talking about the responsibilities of a electronic design engineer. So once the requirements and specifications are received, so the designer must understand the problem definition, and so what are the standards that need to be followed. So based upon the system usage category, it could be consumer electronics, or it could be in avionics, or it could be in medical field. So based upon the application, so the standards will change. So he should have aware about those standards. Then the concept and architecture. Once the requirements and specifications they are in the, so usually the customer give maybe some layman language. If he gives, you need to convert into the electronics language or electrical language. So what is the electronics and electrical language? The voltage, current, power, frequency. So you need to conceptualize the requirements and specifications. So once they are there, so you need to build your block diagram. So in this block diagram, first you need to have, so you can say top level block diagram. So in the top level block diagram, what are the major modules that you need to have? What is the connectivity between these modules that need to be done? Then trade-off analysis. So by doing the trade-off analysis, is you need to finalize the modules. So the interface planning. So in the previous slide, you have seen the interconnection between the modules, right? It could be a power interfacing, it could be any communication level, or it could be any control level. That interface need to be planned. So that interfaced, so suitable connectors need to be selected. So for example, if it is a Ethernet, so Ethernet cable need to be planned. So for an example, right? So you need to have power budgeting. So you know that each module is having its own specifications and its own power requirement. So you know what are the modules that are using in your system, right? So then you need to do the power budget analysis. So if your system requirement is, for example, 60 to 70 watts, so you need to have a power supply of 100 watts to meet the some transient conditions, as well as the, so you should maybe you cannot operate your system with 100% power usage. So that power budget analysis need to be done. Okay, then yeah. So once that is done, then component selection. So component selection for those modules, and for that, even module selection, you need to understand the data sheet specifications. So usually this data sheet is having the three sections. One section is the electrical characteristics, where the absolute and maximum ratings will be there. And second one is the thermal characteristics in the form of graphs. And all the components are temperature sensitive, right? So definitely understanding of thermal characteristics and corresponding graphs are very much required. Then another part is the mechanical dimensions. So mechanical dimensions are also important for your designing criteria. So for any component or module, if you are looking at any data sheet, these three sections will be there. Then so if you are having multiple components, so you need to compare them, you need to select the best based upon your requirements, and you need to do the cost analysis. So you should have the life cycle awareness. So if you are looking at the component, definitely, so if your warranty period is 10 years, so you need to make sure that the component or the module availability is at least 10 years, because you need to sometimes you need to replace those components or modules. So during the component selection, that is required. And schematic design, so schematic design is majorly for these PCB designs. So you should have the circuit design, analog basics, all those things you need to have. Then simulation and analysis, so simulation tools, so all these things may be covered in the next session. And PCB layout, so once this is there, then you need to go for the pro. So this is for one module. If it is a PCB, then these multiple modules will be interconnected, and you need to build a prototype. So you need to assemble all these modules. It could be a RF module, RF chain, digital modules for your digital logic implementation. And so the power supplies for these RF modules and digital modules, some of the application requires analog modules. So all these modules need to be interconnected, so by using suitable cables and connectors. Once that is done, so you need to test it, right? So so initially you need to plan for the, as a designer, so you need to plan for the initial testing and functional testing. And as a designer, you need to give the test case tolerances. So if you are expecting, for example, you have designed a module with 5 volts as the output. For if you are giving a 230 volts AC input, and you are expecting a 5 volts DC as the output, so all modules may not give exactly 5 volts. In that case, you should give the tolerance, whether it is 1% tolerance plus or minus, or 2% tolerance, or 5% tolerance. That tolerance you need to give for the testing purpose. So once that is defined, then so if prototype is proved, then you can go for manufacturing. Okay, right. So after passing all the required quality standards, so what are the typical things that you need to maintain? So you need to prepare the required documents. You need to prepare the high level block diagram and detailed architecture diagram where pin to pin connections are defined. So you need to define the bill of materials, nothing but your components. So your schematics and PCB files. Once all these modules are available, even in this case, so one thing is not mentioned, that is cable. So the cable selection also need to be done by the designer. So once your modules and cables are there, then you need to go for the prototype building. Then so for those you need to define the test procedures, and you need to prove the test procedures, then you can release it for the production, right? So these are the responsibilities at the top level for any design engineer, right? So then what are the skills required? So you should have strong fundamentals knowledge on analog electronics, digital electronics, embedded basics, so microwave or RF basics, the power electronics where the power modules are there, and the PCB design. Even though if you are not doing any PCB design, you are working at the system level, yes, you should have PCB. So you should able to give your views to the PCB design engineer. So that skills are required. And you should have the uh, proficiency in the tools and softwares for our simulation tools, test instruments, right? All the measuring instruments. So as you need to define the test procedure, so first you need to understand what are the testing procedure instruments that are available, what is the capability of that instrument, whether the selected instrument is capable of because if you see if you take a simple oscilloscope. Okay, so it is having its frequency in 50 megahertz, and sampling period will be there. So sampling rate is there. So whether that sampling rate is is capable enough to measure my signal. So all those things need to be given in these test procedures. So that means you need to finalize the which oscilloscope uh, that need to be used. Okay, then you should have analysis skills. So analysis skills, particularly for this power budgeting and RF analysis. So even if you are using the other modules, so you should have the analyzing skills. So see, you should think reliably. So if you say yes, this we can go with this mod with this module, that uh, you should be, see, there is no second chance. There is no second chance in your hardware design, because see, once the hardware is finalized and mechanical placements are locked, so it is very hard to redesign. So if it is a software, yes, you can so you can revise your code and you can port into the hardware. But if the product placements and the module placements, cable connector placements, everything is finalized, so it is very difficult to change again. So that's why, so you should think, see, you need to visualize the final product and its placement. So that is where the reliability thinking comes. And debugging, whenever the problem comes in your regular working of the module, so you should able to debug. So you should find the root cause analysis, right? You need to maintain that failure analysis. You need to do the risk assessment, everything you need to do. So that's why analytical skills are very much important. And process control. So anyway, so under your supervision, maybe a documentation engineer will take care of all those version controls. So you should have quality mindset and change management. So version 1 to version 2. So all these things you should possess in your process skills. And soft skills, always if I say soft skills, all these soft skills, right, is common for all the hardware roles. Now, in that case, every role it is required. So you should communicate clearly what are your thoughts, and you should able to present clearly what you want to present. And teamwork, see, as a hardware engineer, hardware designer, you need to work with software designers, you need to work with uh, project management team, you need to work with mechanical designers, you need to work with system teams. So different teams you need to work with. So yeah, teamwork is always important. Time management, so you should assess, if you are working on a design, you should be able to tell how much time it will take, how many days or how many man hours it requires. So based upon that, you should complete your works. So time management is also very important. And as I mentioned, cross-functional coordination, right? So that is also required. And when it comes to integration, so the first previous role is designer. Once the designer confirms that yes, so this is a final design, then the actual next level, mass level production and production things will come. So the first step is the integration. If your modules are ready and your cables are ready, and the thing is, so you need to go for the system or subsystem integration. So here, from the designer, you should have a document. So in the document, the integration procedures and the BOM required, bill of materials. So here, in terms of modules, in terms of cables, in terms of connectors, the bill of materials, the quantity, everything will be mentioned, right? So whatever the quality checks need to be followed, so everything will be documented from the R&D team or designer team. And you need to understand those requirements. That means you need to understand as an integration engineer. So you need to understand the document. What is the system that you are working, whether it is a RF system or whether it is a digital system or whether it is a power supply unit, right? So whether it is using any radar or whether it is using any jammer right? So all those things, system understanding is it should be there. Use case clarity, as I mentioned, whether it is using any radar, whether it is using a jammer, so use case clarity should be there. And performance targets. So the performance targets in simple words we can say, as if you are giving a input, your system is working as per the expectations or not, right? And its acceptance criteria. So these 4 points understanding must be there, right? Then what are the different electrical interfaces? What are the RF and the other signal paths? So all those things that are available in your document, but first you need to identify. So different types of modules and their placements and their interfaces, everything you need to understand, and mechanical interfaces and mechanical placements. See, here you need to closely understand the requirements or the specifications or placements given by the mechanical engineers, and ICD awareness, interface control document awareness. So see here, this interface control document is defined the pin-to-pin connections. Even the high level document may have the intermodule connection, but this interface control documents will have the pin to pin connection. So you should have the awareness, or you should have the control, so complete clarity on this ICD document. And architecture and integration planning, anyway, it is available in your document, that where you need to do the module mapping. So here there, so SP80 switch, that is mentioned in your document. Here in at the integration level, you should identify. So what is this SPAT module? What is this power supply module? So you need to identify the modules. So that is module mapping. Anyway, power budgeting is always already given by the designer, so you can follow that. So sequence planning. So if you take any LRU, there are different plates will be there. So top plate, bottom plate, side plate, all those things. So first, in some LRUs or some subsystems, you can start with the bottom plate. Sometimes you can start with the left plate. Sometimes you can start with the right plate. So that sequence planning, if it is mentioned in the document, that is fine. Otherwise, you need to plan that. And risk identification during these integration, any problems that you have identified that need to be noted. So then mechanical fitment and packaging. So as I mentioned, so these mechanical fitments are very, very important. So as you are going to use many fasteners, usually called as screws. So yes, so the placements and mounting and all the thermal considerations you need to consider, and you should have the swap awareness. So anyway, this swap analysis will be done by the designer. Size, weight, and power optimization, it is called. You should have this swap awareness. And once the modules are fixed, then cables and interconnections. So these need to be done. So you need, whenever you are fixing the connectors, so there will be thread locks will be there. You need to identify that correctly. So you need to fix that connector properly, and you need to route these cables. Cable routing is very, very important. You should not combine AC DC cables. You should not combine RF cables and power cables. So the cable routing is already defined in your document. You need to follow very carefully, right? So the labeling, even so the even with the reference to the labeling also, the cable routing will be mentioned in your documents. And you should also have the EMI EMC awareness, so electromagnetic interference and electromagnetic compatibility, right? Then so once these subsystem means cables and connectors are completed, then so proper shielding has to be done, proper glue potting need to be done, so no loose wires need to be there, so everything need to be covered properly. Then once everything is done, then the next role that I'm going to cover, that is QC. Probably that is the fourth role I'm covering. So those people will give the clearance. So yes, there is no loose connections. The placements are fine. The dimensions are fine. So everything is fine, they will give the quality, they are having their standard quality checks. Once they have given clearance, yes, you can do the basic power on. So once the basic power checks has been done, the like your voltage verification, so basic functionality thing, then you need to port your software into the uh, defined cards or modules. Then you can check the system level validation. So for system level validation, again, you need to have all the measuring instruments like oscilloscope, multimeter. Even you need to if it is a RF intensified system, you need to use spectrum analyzer, network analyzer. So system level testing need to be done. Once this subsystem is giving the required output, then it is meeting the required specifications, yes, you can hand it over to the next level. So what are the things that you are carrying out? So you need to understand the document, integration document. So you need to understand the interface control document where the pin to pin connections are defined. So you need to follow the integration plan. That means you need to place the modules right at the given designated places, right? You need to give the once modules fixing is completed, you need to interconnect these modules with the help of cables and connectors. You need to properly route these cables as per the assembly drawing. And once the quality clearance comes for the power on, so power on need to be done, and you need to generate a test report, and you can move to the next stage. So what are the skills? So technical skills, again, all the basics which are required for the hardware, their skill requirement is at a higher, very much higher level. Their threshold is very high. Here you need to have the basics there, right? And tools and instruments, all the measuring instruments like oscilloscope, multimeter, spectrum analyzer, right? Even network analyzer, all these instruments and tools, you should have the grip and integration skills. So you need to, you should able to identify the where you need to do the grounding and shielding. So how to connect the cables. So how to identify. See, sometimes I'll give a case study here. So for example, you are having a cable, right? So that cable actually one end it should have a DB9 connector female, but uh, somehow you got a cable that is having DB9 connector male. So will you connect that? You should have that awareness. Yes, this cable should have a DB9 connector with female, right? So those skills you should have. So whenever there is a doubt in the fixing of your component, if any deviation is there with respect to mechanical placement, yes, you need to do some coordinations, right? So you need to test basic functionality power on tests that you need to do as an integration engineer. So you should, as a process skills, you should know what are the modules, nothing but BOM, right? You should know the list of modules in terms of BOM. So you should have so version control. So whether you are following the latest integration document or not. So quality mindset you should have. So you should maintain your test reports in the documentation as a documentation. So soft skills, always communication and team coordination. So the soft skills are common for any role that I'm talking now, right? So this is about product integration, right? Once this product integration, then I'm moving to the modules testing. So module testing, see, as I mentioned, any subsystem, the building blocks are modules, cables, and connectors. So these modules need to be tested before using in your integration, right? So why I have kept this role here means, so this module testing, functional testing, as well as the subsystem level testing, these are having the similarities. So that's why I'm considering this as a single role. This is a either module level testing role or system level testing role. Okay. So first you need to understand the test requirements, right? So if it is a system or subsystem, or whether it is a module, it is going to have a standard testing procedure. Is it is as simple as your laboratory experiment, what is the objective of the test, and what are the operators required, what is the connectivity diagram, right? And what is the, you can say, uh, precautions that you need to take, what is the test procedure, and what are the input values that you need to give, what are the expected values. And tolerances is one of the important aspect. You should know the tolerances. So once tolerances are defined, then finally the result. So like that, every test procedure will be there. So you need to understand the test procedure and acceptance criteria in terms of tolerance, what is the test scope. So you should have the compliance awareness. Then test planning. So once if you understand this document, so what is the sequence of steps. So resource planning. So maybe what are the instruments required, so whether the instruments are available or not, right? So that need to be done. And risk identification particularly, so those precautions will be there. So mostly it will be covered there. And test setup, once if you have done it with your planning, test setup and instruments that need to be done. Then our connections need to be done, whatever the cables interfaces that you are using, that need to be done. So if any test jig is there, you need to use those test jigs. Then once everything is fine, by taking proper precautions, you need to power on. So you need to check, so as per your input values, whether you are getting output. So let us say, as I mentioned in the previous case, my input voltage is 230 volts AC. I'm giving 230 volts AC. Whether I'm getting 5 volts DC output or not, I have given 10% as the tolerance. So 10% of the 5 volts is 0.5 volts. So if my output voltage is coming between 4 point, if I give plus or minus 10%, so whether my voltage is coming between 4.5 volts to 5.5 volts. If it is in the range, yes, I can pass that module. So yeah, that is our functional testing. So yeah, based upon the tolerance, so you can say that yes, this module is passed or failed. Then if the module gives 5.7 volts, so then again, what is the problem? Why it is giving 5.7 volts? So the debugging and failure analysis need to be done, and endurance test, reliability test need to be done. So most of these electronic modules or components will used for continuously. So those endurance tests need to be done. Once those are completed, yes, test reports, all those things can be done. So yes. So what, as a functional test engineer, you will do? So first, you will understand the document. So you will plan for the test. You will follow the test procedure, right? So then you'll fix the test setup, and as per the test procedure, you'll give the inputs and record the outputs. So if the output is within the limits, yes, you pass that with the along with the test report. If it is any failure, and you will go to the debug process. So what are the, so here majorly you need to understand the instruments and testing skills, right? So majorly as it is module level, so ESD precautions, you must take ESD precautions, component level and module level. So electrostatic discharge, so this is a separate topic, so we'll discuss in the subsequent sessions in detail, right? So this is about testing related. And QC. So QC is one of the major aspect. Here we may not do the functional testing, but defined standards will be there. Okay, so based upon the defined standards, right from the procurement. So if you procure a component, then you need to do the inward quality inspection. What is the part number? What is the quantity that we have ordered? So what is the visual condition? Any damage is there? So whether it is a original component or any other counterfeit component, that need to be done at the inward level. So once that is done, so these components can be made as the module. So if a module is there, a module is nothing but on your bareboard, if you are assembling all your components, that is called as module. And even this module, if RF modules are there, they will place in a mechanical housing, and suitable connectors will be placed. So usually that is called as a module. So for module or assembled board, so a quality person checks whether the component placement is correct or not, whether the correct component is placed or not, whether the solder quality is correct or not, the polarity, if it is a diode, so anode is placed perfectly or correctly or not. So polarity or orientation. So any track damage is there, any mechanical dimension wise problems are there. So all those things will be verified in the module visual inspection. And if it is a cable, so the connectivity is there or not between the input pin and output pin, and the crimping is happened correctly or not, the crimping quality, so the labeling is correct or not, the correct gauge wires used or not. So all those things they will verify physically, and they will write the report, yes, this is done. So even dimensions checks will be done for both cables and the modules. And continuity checks. So mostly if you are checking between the continuity between ground and ground, it should be grounded. If you are checking between ground and VCC, it should be isolated before power on. So all those things need to be checked. So continuity checks are required. And functional checks, mostly limited, will be done at the QC level. Environmental checks, that is vibration test, thermal cycling, stress screening. So all these things will be done. So once at every stage, so if QC fails, the module will not go to the next level, right? So QC plays a major role, right? There are different types of QCs, as I mentioned: inwards QC, module level QC. It includes bareboard, assembled board QC, cable harness QC, module level QC, then environment level QC. Even this QC is applicable at the subsystem integration level, as I mentioned in the earlier slides. So all these things are required. So they will use their tools like even microscope, magnifier, multimeter for continuity checking, right? So vernier calipers, all these things for dimensions checking. So yeah, these are the skills that are required. So yeah, as I mentioned, these are the four roles. So what are the four roles? Product design engineer, product integration engineer, test engineer, quality control engineer. So again, these roles are having sub roles. Right, when it comes to UTS, so if you learn these skills, we are having these immediate openings, right? The top categories for hardware and the bottom categories for the software. So these are the number of openings immediately we are having for the fresher level. I'm not talking about the experience level. So if your college permits 6 months internship or 12 months internship, so the relevant all the relevant courses for PCB design, product integration, functional testing, QA and QC, all these courses, as Mr. Anil explained earlier, so all these courses are available at the Gyanidhi. So Gyanidhi is our training partner. So if you complete those courses, okay, and if you declare the completion of that courses as well as the assessments given in those courses, so Gyanidhi people will conduct an AI interview, and they will share the result of AI interview with UTS. So based upon the interview outcome, UTS will hire the candidates. Not only hardware roles, so we are having RTL design engineer in the VLSI domain, SDK developers, firmware developers, and software engineers in the embedded software, and we are having application test engineer role. So we are having huge openings for the freshers. So it is your turn to learn the skills, complete the assessments, and declare your availability for the internship. Okay. So if you require, so you can so Gyanidhi people will give their contact details, email details, mobile number details, so you can reach out them for these openings and the recruitment process. right? Yeah. So here the PCB design course is anyway, as I told, Balu sir will give the orientation on those things. Yeah. So you can log on to Gyanidhi digital courses. So complete the relevant. So see whatever the roles that you are interested in out of these roles, select the course, complete all the video lectures, complete all the assessments, give your completion status to the Gyanidhi team. They will take care. Yeah. Thank you. Thank you for your time.
Thank you, sir. Thank you so much.